Magnetic resonance imaging by Niloyd Elimbuido. By the way, what is MRI? MRI is one of the most commonly used tests in neurology and neurosurgery. MRI provides explicit detail of brain, spinal cord, and vascular anatomy, and has the advantage of being able to visualize anatomy in all three planes: axial, sagittal, and coronal. These are the topics to be discussed. First, the difference between TR and TE. Second is the relationship between TR and TE to T1 and T2. Third is T2 and proton density. Fourth is K-space. And lastly, phase and frequency encoding. So first is the difference between TR and TE. Repetition time or TR is the amount of time between successive pulse sequence applied to the same slice, or while the time to echo or TE is the time between the delivery of the RF pulse and the receipt of the echo signal. Second, relationship between TR and TE to T1 and T2. As I've said earlier, repetition time or TR is the amount of time between successive pulse sequences applied to the same slice. Time to echo or TE is the time between the delivery of the RF pulse and the receipt of the echo signal. Tissue can be characterized by two different relaxation times, T1 and T2. T1 and T2 are technical terms applied in different MRI methods used to generate magnetic resonance images. Specifically, T1 and T2 refers to the time taken between magnetic pulses and the image is taken. These different methods are used to detect different structures or chemicals in the central nervous system. T2 and proton density. By the way, what is T2? T2 or transverse relaxation time is the time constant which determines the rate at which excited protons reach equilibrium or go out of phase with each other. It is a measure of the time taken for spinning protons to lose phase coherence among the nuclei spinning perpendicular to the main field. The definition of proton density. Proton density images were extensively used for brain imaging. However, they have largely been replaced by FLAIR. However, continues to offer excellent signal distinction between fluid, hyaline cartilage, and fibrocartilage, which makes the sequence ideal to the assessment of joints. K-space. Okay, the definition of K-space is the K-space represents the spatial frequency information in two or three dimensions of an object. Sorry. The K-space is defined by the space covered by the phase and frequency encoding data. The relationship between K-space and data and image data is the Fourier transformation. How is the K-space field MRI? The easier way to fill the K-space is to use line-by-line rectilinear trajectory. One line of K-space is fully acquired at each excitation containing low and high horizontal spatial frequency information, contrast and resolution in the horizontal direction. What does k-space looks like? The cells of k-space are commonly displayed on rectangular grid with principal axes kx and ky. The kx and ky axis of k-space corresponds to the horizontal x negative and vertical y negative axis of the image. The k-axis, however, represents spatial frequency in the x negative and y negative direction rather than positions. Please refer to the picture. Okay, move to the next slide. Phase and frequency encoding. By the way, what is the difference between phase and frequency encoding? The frequency encoding direction is along the x-axis in that space, may or may not be that axis in the image if it is rotated. This represents the time samples of the signals. The y-axis is the phase encoding direction. Each phase encoding steps yield a separate horizontal line. Phase encoding. A magnetic gradient field is applied briefly in one direction as the change in frequency is very brief. When the gradient is switched off, it causes a change in phase that is proportional to the distance. Frequency encoding is used to determine one axis in a XY plane of the slice. Just like the slice section, remember that the represent of the magnetic field gradient creates a corresponding gradient in a precession frequencies of the proton along the direction. The end. Thank you for listening.